All right. So let's talk about testing functions. What kind of functions are we should we be testing? Let's have a deeper look about this unit testing. And basically, when we are doing unit testing, we are testing functions because they are actually the building blocks of our programs. Functions, methods, okay, modules. All right. So what does testing function really mean? So, what does testing functions really mean? Testing functions are equal to verifying that a function. So, when we say we are testing a function, okay, what are we doing? We are verifying that that function returns the correct output. So when we have an adder function, when we give it 2 plus 3, it's supposed to return 5. So that is the correct output. So that is what we are testing. We are verifying that the function returns the correct output. The function handles all possible inputs. Now, when we have an adder function, if the user gives us um, um, all the possible inputs, we're taking a look at all of them. If the user gives us a negative number, if the user gives us an undefined value, if the user gives us anything, we're taking a look at all the possible inputs. So we are testing against all the possible inputs. We also verifying that the function fails safely when needed. So when the function fails, it should fail safely when needed, okay? So a function is the smallest testable unit of logic. So a testing function is the smallest testable unit of logic. So the core principle here is that if a function is easy to test, then it is well designed. So basically, this is also going to help us to start designing functions that are well designed. So any function that you create, it should be tested. It should be a testable function. Do you understand? So this would also help us in building or designing functions more accurately, well-designed functions. So now when you design your functions to be easy to test, that means you're designing it well. All right. So types of function we should test. All right. Number one is pure functions. So these are the best cases. So basically, whenever you're writing your function, they have to be pure functions. And what are pure functions? A pure function has no external dependencies. Okay, let's assume our other function, when you give it 2 plus 2 and 3, it should return, it has no external dependencies. It's not depending on any other function. Okay, it just does a single job. So every function should just do a single job, a unit of functionality. Okay, same input, same output. So whenever you give, how do you know that a function is pure? Whenever you give it the same parameters, the same input, it will give you the same output. So it's very, very predictable. Do you understand? So when you give another function 2 and 3 to always return 5. If you give it 10 and 5, it will always return 15. Okay, so look at this add function now. All right, it's returning a plus b. So whenever for whatever input you give it, you always expect the same output. So this is a pure function. So these are kind of functions that are testable. Okay, testing functions. So now when you write this, okay, we are expecting it to be 5. It will always be 5. We give it 2 and 3, it will always be 5. So this is a testable, a pure function, and this is the best case. All right, for all the types of our testing function, this is the best case. All right, so it is very simple. Design your functions so that they will be very simple, pure functions, no external dependencies. Okay, same inputs will get the same output. These are easy to test and they are ideal. Pure functions are the best case. So we also have functions with logic. Okay, now let's assume now that we have to write a function to check if a number is even. So this has some logic in it. It's not just doing a plus b. All right, it's doing some logic. It's checking if the number modulus 2 is equal to 0. So this is some kind of logic. So we can also test this function. Okay, so when you test this function, the function returns something like this. Okay, so we are very sure that when we give it an even number, it will return true. When we give it an odd number, it will return false. So let's do something here. I will go to my unit testing folder, and then okay, so let me just go to the same other folder. All right, so First of all, remember, we have to write our test first before our functions. So I will come in here and then I will create, instead of the file, I will create a file and I will call it is even dot test dot js. Okay, dot js. So I am going to create, I'm going to write the test first. So test, okay, so it should returns returns um, returns true for an even number. Okay, then what is the callback function? So in here we will write expect. So let's call the number is even. So when we call this is even, pass in 4, all right, is even to be true. All right. We can also use the other matcher. We'll talk about it to be truthy. We can also use it to be, you can also use to be truthy. Okay, so now we have written this function, this test. Let's also write another test that will also pass, will also fail for, so returns false for an odd number. So if I pass in 3, all right, it should return false. So now, if I go on and run my test, okay, I can go npm test, all right. It will run the test, but remember, I have not written the function, so it's going to fail. That is our red-green refactor. So I expect it to fail. All right, look at it, has failed. Okay, so 2 tests failed. So if I go back, you see that is even is not defined. So let me just go and create the is even file. Is even.js. So I will create the function export default is even. All right. Oh, sorry. Is even. So it will take parameter, a number parameter, and then it will return. Oh, sorry. The function keyword is supposed to be there. All right. Oh, sorry. So it should return num modulus 2 equal to 0. Num modulus 2 is equal to 0. All right. So if I go back to the is even.test.js, I just have to import this is even. All right. And once we do that, our test is going to run again. And I expect it to, you can see it has passed. All right, it has passed. So this function has logic. The is even function, it has logic because we are doing some Boolean logic here. If num divided by 2 is equal to 0, that means it is even. If not, it is not an even number. And if you look at our test, we are trying to check the result of this is even to be true because we are passing in 4. When we pass in 3, which is an odd number, we expect it to be false, and it passed. All right. So we also test for functions that throw errors. We should also test for functions that throw errors. So let's assume now we have a function divide. So we have a function that does division. Now, first thing we have to do is that we have to check, because you cannot divide by 0. If you try to divide by 0, there will be an error. So we have to catch that error beforehand. So if the b, all right, is equal to 0, we are throwing error, cannot divide by 0. So these are the kind of functions we can test. So with the test, we can go and say expect divide 10 and 0 to throw cannot divide by 0. So if I go on now, remember, I will have to write the test first. So I will call it the divide.test.js. So I am going to test, I will say throws an error when divided by 0. Okay, and remember, this could be invalid cases. Remember the kind of, when we talk about normal cases and edge cases, this could be one of the invalid cases, because if you don't take care of this, the user can just give you 0 as the divisor. Okay, so now we expect, all right, we expect that divide 10 and 0, we expect it to throw, okay, we expect to throw, I hope I got it right. We expect to throw, now we can use the exact error message, or we can use, what's it called, regular expression. So in this case, I just want to make sure that there is, cannot be divided by 0. I just want to have cannot be divided by 0 in the error message. Okay, so now I have written this, but of course you can see that our test is going to fail. All right, so now let's go and fix it. Let's write the divide.js. So I'm going to export default function divide. Okay, so this divide is going to take in, divide will take in the denominator, the numerator, and the denominator. Which one comes first? Numerator, denominator. I think, all right, numerator, denominator. Okay, all right. So now I am going to check if denominator is equal to 0. We could even check if it is less than 0, maybe negative numbers. I don't know. It was negative numbers. Okay, a number can be divided by a negative number, so we don't have to do that. So if this is equal to 0, we have to throw new error. We'll throw new error. And in our error messages, in our test, we are trying to check not divisible by 0. Okay, not divisible by 0. But guess what? This is going to fail, because you can see that I was checking in the error message, in our test, I was checking for another error message. So, but if that is the case, if it's not the case, if din is not equal to 0, so what do we want to do? We want to return num divided by denominator. Okay, so I'll save this. I'll go to the divide test, and then I will import this. But guess what? It's still going to fail. I want you to pause this video and tell me why. It's going to fail. It's going to fail. Now look at it. We are expecting shows an error when divided by 0. Okay, not divisible by 0 is what we got, but we are expecting it to have this to match this regular expression. So since not divisible by 0, I can just say not divisible. I may be confusing you here. Not divisible by 0, and it will pass. Oh, it's also failed. All right, so this is where I think I made this mistake yesterday too. So this is where I got it wrong. Throws an error. So okay, you can see now, because I am using a regular expression, that is why it's failing. In my regular expression, I expect it to say not divisible by, you can see I made a mistake here, divisible. So because I am using regular expression, not divisible by 0 is different from what I expected. So now you can see that everything has passed now. All right. So, but you can also look for the exact this is regular expression, but if you don't understand regular expression, I can just go with the exact error message. So when you're looking for, if you're testing for functions that throw errors, you must make sure that the error message, the string here must match it must match your error message. So you can see that it has also failed for some reasons. I don't know why. So let's go. Okay, so it should not divisible by 0. Not okay. Let me just maybe copy the exact error message. But I think they are the same. Not divisible by 0. Let's see. Okay. All right, it passed. All right, everything passed now. So we can also maybe add another test and say it should return when we divide. I could also say write another test here to check to make sure that it's working. I can say returns to when 4 is divided by 2. So I can now go on and of course I wouldn't use this again. And remember we have the AAA pattern, right? So I can say 4 and 2, but in this case it will be the matcher we are using here will be to be 2. So let's see our test. It should pass. All right, because 4 divided by 2 will give us 2. All right, so it passed. So we can also check, we can also test functions with arrays. So you can see now that this array, I will leave you to this to handle this. We have this function called get total, all right? It will take expenses. This expenses is an array, all right? So we are using the reduce method to have a sum of all the numbers in the array. Now this is the test. So when we have 100, 200, and 300, the total should be 600. So this is the test. But we should also write test to check if the array is null. Sorry, if the array is empty, or even if the array is null, because this could be the other invalid cases, the edge cases. All right, here we have just tested it, it has just gone null. But what if the user, instead of the user giving us an array that has some items, the user gave us an empty array, or even the user could even give us a null value. So what happens? Do you understand what happens? Okay, so we should also check those things. So I believe at this point, if you have understood what I have been doing so far, you should also write a test that should check if the array is empty or if the parameter or the argument to the get total is null. All right. Okay, so we can also check for functions with objects. So look at this get full name. The user is an object. So we are returning, okay, so here we are making sure that when we call the get full name and give it an object, it should return, we expect it to be John Doe. This is somehow simple. Now, if you have been following me so far and you understand what I'm doing, this should be okay. It's just your logic, okay? But the thing is that I want you to also look at this as examples. I want you to also test, what if we have a middle name? So you should also write a test that should check if the user has a middle name, because in this case now we are not the function is not even taking care of if the user has a middle name. So those edge cases, a user could also give you their name, their first name, their last name, and their middle name. What happens? So I want you to do that too. If you cannot do it, that means you've not been understanding what we have been doing so far. Please contact me. Okay. What exactly are you testing for? What we are testing for the output correctness. We want to make sure that the functions that we are writing, whether we are writing it for a library or for anything at all, even for our own code, we want to make sure that the output is correct. Okay, does it return the right result? When I give an other function 2 and 3, would it return 5? When I give it 7 and 3, would it return 10? So we are testing for the correct output. We also Input handling. Now, if you write a login function, a function that handles the logic, sorry, the login of your system, okay, would you also check the input handling? So what if the user were supposed to provide their password and they did not provide it? What if the user was supposed to provide a password that is at least 8 characters or maybe contains some alphanumeric characters and it doesn't? So you should also test for the inputs. Does it handle numbers, strings, arrays, objects? There are so many things. So the thing is that according to the business logic of your application, according to the business rules of your application, you should actually test for all these things. All right. So we're also checking for edge cases. What if the user gave you an empty value? What if the user gave you a 0 and you wrote a divide function? What if the user gave you negative numbers? You were expecting them to give you the name of the value of their age and they are giving you negative numbers. What happens? What if they give you invalid inputs? We also check for invalid inputs, wrong data type, missing values. We could be expecting 3 parameters and they are giving us 2. We could be expecting 2 parameters and they are giving us 3. So these are the things we actually test for, okay? We also check for errors. Does it throw errors when it should? Because, of course, our function should be throwing errors when necessary, okay? So let's take a look at some core jest matchers you must master. The first one is to be. We have used this thing a lot. To be. So when I say 2 and 3, it is to be 5. So all you have to do is to visit just documentation, take a look at their matchers. Okay, go and master their matchers. We have to be. So we expect 2 plus 2 to be 4. So it gives you the exact output. So 2 plus 2 must give you 4. All right. We also have to equal. This to equal is for objects and arrays. So this array 1 and 2 is equal to 1 and 2. So we cannot use to be for objects and arrays. All right. So we use to equal for objects and arrays. To true. All right. When you expect that a function should throw an error, we use the to throw. But instead of this to throw, the argument should be the exact error message that function is throwing, or maybe a match, maybe using a regular expression to actually get a subset or a substring of it. So we expect divide to throw an error. Another one is to be truthy. So in that case, in the case of let me show you how you use the truthy. Okay, so in the case of our is even, okay, so we expect is even to be true, but we can also say we expect it to be, is it to be truthy, right? Did I get it to be truthy? Is that correct? Let's check. Okay, it's correct. It passed. Instead of saying to be false, we can also say to be falsy. All right, and then let's take a look. It also passes. Okay, so these are how you use it: to be falsy, to be truthy, to be even. Okay, sorry, not to be even. To be, these are common. To throw, to equal, to be. These are common. So if you also want to check an array, so maybe you want to check if an item is contained in an array, or maybe if an object contains anything, you can also use to contain. We could even try to say if a string contain, okay, a particular, I have not tried it before, but let's try. Let's give it a try here. I could just write another expect here. I could say um, expect hello world to contain, I expect it to contain HE. So let's see if it passes. All right, you can see it passes. All right, so it can work for strings, it can work for arrays. I believe it can also work for objects. I've not tried for object before. Let me try an object here. I don't try, I've not tried it before, but let me say name is John. So to contain Let me see. I have not tried it before, but let's see. To contain name, but it throws an error. It doesn't. Okay, it failed. Received. It's not an iterable. Okay, the object is not an iterable. That is why it failed. Okay, so it returns. See, what we received is not an iterable. Okay, that is why. All right, all right. So, but if this was an array, it could be something like this, and then this array has name, so it will work for an array. All right, it will work for an array. So this array contains name. All right. Okay. So remember the AAA pattern. All right. This is the best way to go about it. When you're writing your text, make sure first of all you arrange. All right, you arrange. So arrange is something like this. After you call a function, then you now assert the result. So now let's go back and okay. So with this now, let me arrange here. Here I'm going to say const num is equal to 4, right? Then let me add, I will now say const result is equal to is even of num. Then let me now assert. Sorry, yeah, let me assert. So assert is where I now call my is even. So instead of checking is even, what am I checking here? I'm checking the result that I got. All right. So I have used the AAA standard pattern. So this is cleaner. This is cleaner. So always try to use the AAA pattern. All right. Always try to use the AA pattern. So real world example. So now we are testing for. So we have a function. So this is a test. So we are supposed to create a function that filters. It filters expenses above minimum. So we'll give the function an array and then give it the minimum. So it will filter the minimum. So this is the test. We have two tests here. So the first test is filtering. We have the filter expenses function. So we give it an array and also give it the minimum value. So it will now filter. So when we give it something like 100, 250, and we are giving it the minimum to filter, it will return 10 and 100 and 200 because 50 is less than 100. So I am not here to write functions. I'm here to talk about unit testing. Okay, so now we also have another one. We are filtering when we have, in case we give what we have in the array is lower than the minimum. Everything we have in the array is lower than the minimum. Of course, it's supposed to return an empty array. So that is the second test here. So you can actually take in this test, the two tests. Now, but let us write a function. First of all, it should filter expenses above minimum. That means when we have in our expenses array, we have 100, 200, 300, and then 450. So when we give the minimum to be 100, it should filter off the 50 because 50 is less than the minimum. The minimum is greater than, is above 50. So it will return 100, 200, 300. But if we give it 20, 50, 100 as the array, and then we now give 200 as the minimum, of course, it should filter, it should return an empty array. So that's what we have here. So this is the function. All right, so this is the function. We are using the filter method. All right, so we expect that this expenses is an array and then the minimum amount. And again, you can see that we can also check for if the array, if the expenses is an array. If it's not an array, we can throw, okay. Let's do this. Let's do this. So let me write, first of all, of course, I will write the function. I will write the test first of all. So in my test, I will call it filter. I didn't want to write this, but let me just write filter expense dot test dot js. Okay, so first of all, we are testing returns. What's the this thing again? Let me just go. Filters expenses above minimum. Okay, so that is it. Filters. It doesn't even matter. Your description doesn't matter. But I just want it to look good. Filters expenses above minimum. And then this is our callback function. Okay, so we should so with our arrange, so let's go arrange. Okay, our array will create we'll create an array here. We call it expenses, and it's going to be an array of 100, 200, 300, 400. And then we also have another variable here. We'll call it minimum. Okay, we'll call it minimum, and the minimum here is 100. Okay, and then this is our array. So let us add. All right, let's add. So we are going to call, we say const results array. So this is the array result that will be returned. So we are calling expense, no, we are calling filter. Remember, we are supposed to write the filter expenses. So we don't have it yet, but remember, our test should fail. The first time we write our test, it should fail because it has to fail. That is the red, green refactor. So it will fail. Then we'll now go and write the function that will make it pass. So filter expenses, I will give it expenses, and then I would also give it minimum. Okay, now let me assert. Okay, so assert is now we expect rest array to be what? We expect rest array to be this because we expect it to be 200, 300, 400. All right, so that's what we expect it to be. So now let's go, and of course it has failed because we don't have that function at all. We don't have that function. So let us go and write the function. Let's write the function. So I'll call it filter expenses.js. So I'm exporting default function. The name is filter expenses. So it will take, it will take an array expenses. It will take an array and also minimum value, the minimum. Now, what are we doing here? We are just trying to return expenses dot filter. Okay, expenses dot filter. We want to filter expenses that are we want to filter. We want to return all the we want to filter all the expenses that are greater than minimum. I hope my code works well. So I save it, and then I'll go to I'll go to my filter expense function. Then I have to import this filter expenses. All right, so let's see what happens to our function, our test. So it failed. All right, so let's see why it failed. So we expect it to okay. All right, you see that mistake I have made here. You don't use to be for arrays and objects. What do? We use to equal. So that was the error. So we used to equal, and you see it has passed. It has passed. So you can see our function, that means this our function can have passed this test. So we can also write another test. Another test could be, what if the expenses is not an array? All right, so let me write another function. So I will have this expense, And in this case now, expense should throw an error if expenses is not an array. Throws error if expense is not an array. So these are possible cases you could check. So what if this expenses is not an array? What if it's just an object? All right. So what happens? So what should happen here is, okay, so I'm not going to do this. Okay, so maybe I will not be using, okay, so I have this. I might not be needing this. So what I will do here is, because it's showing, we are going to throw an error. I will do this. I will say filter expenses. I will pass in the expenses and I'll pass in the minimum. And then I expect it to throw. I expect it to throw. And the error message, I expect to have something like not an array. All right, not an array. Maybe I could use the, okay, let me not confuse you, please. Not an array. Expenses is not an array. So you can see now that, of course, it is failing. One has failed. What do we have here? It is expenses filter is not, it's not a function. Expenses is not an array, but receive message expenses dot filter is not a function. Okay, so you can see we are having this error. So let's go and fix it. Filter expense. So now I want to make sure that if there is this function that is array dot is array, this will return true or false. If expenses returns false, so I'm going to negate whatever it returns here. All right, I will negate it. If this is true, that means we should throw new error. And then the error message should be expenses is not an array. All right, so if I save now, let's see what happens. So you can see it has passed. Now, what are we doing here? We write our test first. So whenever we write our test first, it should fail. We should write tests that will fail. When they fail, that is the red. There's a principle called red-green refactor. That is, I don't know whether it's a principle, I don't know what to call it, but red-green refactor. Your test your first time, your test should fail. When they fail, you now go and fix them. That is from red to green. So when they failed, you can see they are red. When they pass, they are green. Then you can also refactor. And when you refactor, your test should always pass. So you can see what we have done here. All right, so empty edge cases that we should always check. Check if the array is empty. All right, check if the array is empty. Always check for empty input. Always check for null or undefined. All right, always check for large values. All right, invalid cases. All right, when they are, like in this case now, we don't expect the deposit to be a negative number. No, so you should throw an error. All right, so always check for these things. We don't expect the deposit to be 0 or negative, so always write tests that will check for these things and then refactor your functions to actually pass this test. Okay, so look at this bad test. Get user balance ID, and it says db.getUser. So you can see that it has some external dependencies. It's bad. All right. So, but this one is good. It doesn't have any external dependencies. That's the pure function we are talking about. So always remove dependencies, and it makes easier. It makes testing easier. Okay. Understand your function behavior. That's testing strategy. Make sure you understand the behavior of your functions. Then write test cases. Write normal cases, write edge cases, write invalid cases against the behavior of your function. Before you write any function, you should understand the behavior of your function. All right. So once you understand the behavior of your function, do not write the function first. Write test cases, normal ones, edge cases, and invalid cases. Then after writing the test cases, you can now write the function. After writing the function, then you can now refactor safely because your test would always be your backup. If you refactor your code and your test fails, that means it is not correct. And the thing is that when you have all your tests, you write all your tests and they all pass during development, you can push your production, you can push it to production because you're maybe somehow guaranteed that they will not fail, they will not break. Okay, so this is your assignment. Build functions, add, subtract, divide, withdraw, filter expenses, build these functions. First of all, of course, you should write their tests, write normal cases for each and every one of them, edge cases for each and every one of them, and invalid cases for each and every one of them, okay? So final insight, testing functions is not just about checking outputs, it's about designing better logic, handling real-world failures, writing production-ready systems, and this is where we'll call it draw the curtain. This is where we draw the curtain. So please, if you get confused by anything at all, please come to the WhatsApp group, come to the community. Let's talk about it. Drop your questions, okay? And then I will help you answer them. Thank you very much, and I'll see you in the next class.